The following is a tutorial on writing formulas for compounds. So in our first example, I have aluminum hydroxide. So when I look at my periodic table, I see that aluminum is a metal, and then hydroxide is made up of oxygen and hydrogen. So typically when we have a compound that ends in IDE, that would mean that we have a binary compound. However, the exception to that is the polyatomic ion hydroxide. And we know that because hydroxygen is not an element on the periodic table. Okay, so we would look up hydroxide, and it has a -1 charge. And then aluminum has a +3 charge. So I have aluminum 3+, which I am combining with hydroxide, which has a -1 charge. So what I want is for these charges to add up to 0 when I put them into a compound. So by definition, an ionic compound is going to have the charges balanced. So the lowest common multiple between 3 and 1 is 3. So how many aluminum would I need so that it adds up to +3? That would be just 1. And then 1 goes into 3 times. So I would need 3 hydroxide ions. So if you need more than one of a polyatomic ion, you have to use parentheses. So I'm saying I need 3 OHs. It's the OH altogether that has the -1 charge. So what I'm showing here is I've got Al 3+, and then I have 3 OH minuses. Okay, so +3, and then -1 plus -1 plus -1 equals -3. So overall, got +3 and -3. So the charges add up to 0. Okay, so this is your answer right here. Okay, in the next example, it says phosphorus tribromide. Whenever you see a prefix like this, that's typically going to indicate that you have a covalent compound. Okay, and we can double check that right here because phosphorus and bromine are both nonmetals. Okay, so there's no prefix in front of phosphorus, so that means I have just one of them. So P. And then tribromide, which means I have 3 bromine atoms. Br3. Okay, on our next example, I have silicon tetrafluoride. So this right here is going to indicate I have a covalent compound, but I'm going to go ahead and look at my periodic table. Silicon is a metalloid, so it actually does make covalent bonds. So silicon and fluorine. So 1 silicon, because there's no prefix in front of silicon. Tetra means 4, so 4 fluorine. Okay. The next one, I have potassium dichromate. So don't let this prefix right here screw you up, because potassium is a metal. Okay, so this does not end in IDE, so I know I'm going to be looking for this on my chart for polyatomic ions. Okay, so dichromate. Dichromate is right here, so Cr2O7 with a 2- charge. Cr2O7, 2- charge. And then potassium has a charge of +1. Okay, so the lowest common multiple between 1 and 2 is 2. So 1 goes into 2 times, so I'll need 2 potassium. And then 2 goes into itself 1 time, so I only need 1 of those. Okay, you can also use the crisscross method. Since we had a charge of 2 up here for the anion, that becomes a subscript for the cation, okay, and vice versa. So I've got +1, so the subscript of 1 goes for dichromate. Okay, next example, sodium sulfide. Okay, that IDE ending means I've got a binary compound. Okay, remember the exception to that is hydroxide. Also, cyanide is a polyatomic ion. And you'd be able to figure that out because you wouldn't find this element on the periodic table. Okay, so I've got sodium sulfide, so sodium and sulfur. Sodium makes a positive 1 ion. Sulfur makes a negative 2 ion. So I have Na with a positive charge, and I have sulfur with a negative 2 charge. Okay, the lowest common multiple between 1 and 2 is 2. So 1 goes into 2 2 times, Na2, and 2 goes into itself 1 time. Okay, again, if you're using the crisscross method, the cation charge was 1, so that becomes the subscript for the anion, and we don't need to include that 1. Okay, it's assumed, and then the charge on the anion, 2, becomes a subscript for the cation. Let's go ahead and box these answers. Just as a reminder, okay, this is just to help us figure out what the formula is going to be. This is not your part of your answer. Okay, magnesium fluoride. So I've got the IDE ending. So I'm talking about magnesium and fluorine. So magnesium has a 2+ charge, fluorine has a negative 1 charge. So I have Mg2+ with fluorine 1-. Again, my lowest common multiple is 2, so I will need 1 magnesium, 2 fluorine to add up to negative 2. So we're trying to add up to 2 overall. Okay. Calcium nitrate. So it doesn't end in IDE, so I know I'm going to be looking up polyatomic ion. Okay, and calcium is a metal. So we look up nitrate. Nitrate is NO3 with a negative 1 charge. Then calcium was in group 2. It made a 2+ ion, according to our periodic table. Okay, so the lowest common multiple between 2 and 1 is 2. So we need 1 calcium to add up to positive 2. And we will need 2 nitrate to add up to 2. So we're going to need to use parentheses. If you need more than 1 of a polyatomic ion, use the parentheses, and then the 2 will go on the outside. Okay, so if we have 1 of these, which has a positive 2, I'll show you a visual here, and then we have 2 NO3s. Okay, the positive and negative charges cancel out. I've got positive 2, negative 1, negative 1. Okay, iron 2 oxide. So iron is a transition metal, so that's why the charge was given to you. So this Roman numeral is the charge on iron. So what that means is we have Fe2+, okay, iron 2, and then oxygen has a negative 2 charge. Okay, so if we just combine these the way they are, that's going to add up to 0. Positive 2 plus negative 2 equals 0. So our formula will just be FeO. Okay. So next one, we have manganese 4 hydroxide. Okay, remember hydroxide is a polyatomic ion. We already showed up here at the top that it's OH with a negative 1 charge. And then it's manganese 4, which means we have a 4+ ion. And we're combining that with OH, negative 1. So the lowest common multiple between 4 and 1 is 4. So I will need 1 of these to add up to 4, and I will need 4 of these to add up to 4. 4 times 1 is 4. Okay, so now we have to use parentheses because we need more than 1 of these. Okay, next example, zinc 2 sulfate. Doesn't end in IDE, so I know I'm looking for a polyatomic ion. SO4 2 minus. So we have zinc 2, which means it's 2 plus, and then SO4 2 minus. Okay, positive 2, negative 2 add up to 0. So our formula will be zinc SO4. Let's do one more example. Let's do calcium phosphate. So calcium is a metal, and I'm combining that with phosphate, which is a polyatomic ion, PO4 3 minus. So I have calcium 2 plus, and I'm combining that with phosphate, which is 3 minus. Okay, and we want the charges to add up to 0. So we've got positive 2 and negative 3. So the lowest common multiple, the smallest number that both of those go into is 6. Okay, so how many 2 plus charges do we need to add up to positive 6? And that will be 3. And then how many negative 3s do we need to add up to negative 6? That would be 2. So PO4, 2. Okay, we've got 3 calcium ions, which is 2 plus, and then 2, 3 minus. Okay, so negative 3 and negative 3, that's negative 6, and then positive 2, positive 2, positive 2, that adds up to positive 6. So overall the charge is 0.